So this first picture I have up here I want to talk about just briefly. This was our last operation we just came back from about 2 weeks ago. We were up in Nome, Alaska, trying to look over the harbor area, preparing the harbor for the Russian tanker Rinda to come into port to unload its fuel. Here in the foreground, not very visible on the overhead, I apologize, this is actually one of Alaska Department of Environmental Conservation technicians out on the ice, trying to look at and get a perspective of what the ice is going to be, what's it going to be like to drag the hoses over and do a spill response. Obviously, what we were there to do was try to give them a different perspective of the ice and the ice conditions than what you could get from 6 feet up in the air. So, climbing over those ridges. So, unmanned aircraft have been active in Alaska. We've been active at the university, actually, with them even since about 2003. In the fall of 2003, the Coast Guard and the Navy joined in an effort to try to use unmanned aircraft to do maritime fishing patrols in the Bering Sea. And so we did some operations out of Kingstown, Alaska with the Predator. These are a couple of Navy Predators they brought up in that time frame. That was our first operational experience in Alaska using unmanned aircraft. The focus at the university up here has been on the applications and not so much on building the aircraft themselves. And you'll see that throughout the presentation. Give you a feel for the size, this is one of the U.S. Coast Guard C-130s on the runways out of Kingstown, Alaska, and the Predator, taxiing in back into the hangar at the end of a mission. These aircraft are flown from essentially a cockpit in the back end of a trailer. So there literally is 2 operators inside there. Either side could be turned into the pilot of the aircraft or the payload operation, and they can swap back and forth. Today, this aircraft actually is being taken out of the Air Force inventory in preference of it's been replaced already with the Reaper, the next generation Predator. But there are still quite a few of them flying for the Air Force. And they fly from that same console configuration. Some of the other aircraft actually are being flown in Iraq and Afghanistan from airmen on the ground in the United States. Another aircraft that's been in Alaska, I don't have any pictures of it flying in Alaska, unfortunately. It flies pretty high, is the Global Hawk. This actually, to give you a feel for this, the wingspan of this aircraft is the same as a 737. So this is a fairly large aircraft. This is the biggest unmanned aircraft in the world. It's part of the U.S. Air Force's fleet. The Navy owned a couple of these, and NASA actually acquired a couple prototypes, the early prototypes from the Air Force. NASA has flown them over Alaska up into the Arctic Ocean for trying to basically be a dedicated satellite, a pseudo-satellite, to do measurements from 65,000 feet. The Air Force has flown them up to image some of the interior Alaska, some of the range complexes up here. So just for completeness of what's been going on in Alaska. I want you to be aware that this technology, though, is not new at all. This is in 1995. So I know the technology exists, but how to use it wisely for the civil market is some of the work we're trying to do here at the university. We don't envision ourselves as being operators of these aircraft routinely for a project, a science project, or industry project, but we really want to look at the Pathfinder missions. The university's role is trying to find new opportunities for the technology, expose the market to the technology, expose the technology developers to to the industry really needs, and try to be the incubator, if you will, to get some of that work started flowing. And so as a result of that, we really do a lot of one-off projects, 1 or 2 times out to do an experiment, and then hopefully it can transition if it's appropriate. And being in Alaska, we have a focus on the Arctic, obviously. Some things that this technology makes sense to use it for. Personally, my belief is that this works well for natural resource management. Remote areas, climate change studies, emergency response. Places that I don't personally feel like it's going, at least we're not pushing it there, others are around the country, are in urban areas. Venues flying over Super Bowl, flying over a big football game, something like that, flying around those kind of events. People are doing that. It's just probably not the university's best role. Something you have to consider when you want to use these aircraft, though, is it really going to be cost effective for your job? Just because it's new technology, it might be sexy technology, some geek like me might consider, doesn't always consider it necessarily economically wise. And if I can go rent a Cessna aircraft and carry my instruments, it's probably less expensive. The places these planes, particularly these bigger planes, make sense is when you want to do an operation that is not a safe place to be for a human operator, like in a volcano erupting or hundreds of miles out to sea, taking lower altitude photographs. Speaking of out to sea, this is a project we did in 2009 with NOAA. Out of the Central Bering Sea, there's 3 particular species of ice seals. These are seals that live on the edge of the ice floe. They basically haul out on the ice, they pup on the ice, they live the ice instead of on beaches. They're very sparsely populated out there. They're spread out all over the ice edge as it moves into the Arctic Ocean and back down into the Bering Sea. The challenge NOAA has is, this is actually several challenges. One challenge is this is food for polar bear. And the polar bear, are they endangered, are they threatened? What's going on with polar bear concerns? NOAA had a task to figure out what is really going on with the ice seals. And it's a challenge to survey these animals. You're trying to capture a very large area, animals spotted here and there. They're not very large, they're about the size of a human, maybe a little smaller even. And if you do it with a manned aircraft, you've got to fly 300-400 miles from the nearest airport. And then you've got to go down to 300 or 400 feet in altitude, at least under 500, to take your photographs. Not the best place to be if you're a manned pilot or a pilot biologist. Several have died in the last 20 years flying these kind of missions. They just don't come back. The other option you have is if they fly a helicopter off of a big ship, like an icebreaker with a helideck. And that's fairly expensive to get both the helicopter out there as well as the ship. Not to mention, both of those aircraft scare the animals. These animals are sitting on the edge of the ice, and if they hear noises coming they're not used to, they just jump back in the water probably. So all the pictures they've ever taken show these animals up on their flippers looking at the sky. You have to wonder how many animals were really not photographed that should have been photographed because they were spooked. So the question is, could an unmanned aircraft actually do this job more efficiently than a manned aircraft and safer? And for less expense because we can work off a smaller boat. So it's flown from onboard the ship. Normally this would be a map that we'd see the terrain and roads, the rivers and things. There's nothing to see, so we didn't have anything there. But these green dots, it's essentially a breadcrumb trail. You know, here's some bread over knowing how to get home, where we've been. We built a payload on this. We carried the exact same camera on this aircraft that NOAA carries on their helicopters. So when we did the comparisons of the system, we didn't have to compare payloads and airplanes. We had to compare the airplane performance. We gave NOAA 30,000 photographs of sea ice. kind of exciting. They then had the task of finding the ice seals in the pictures. Good luck. Actually, there's some ways to do that better, but if we go out again with them, we'll actually have a system that's help detect that. Yeah. Now, Don here is actually landing the aircraft. So the plane essentially flies itself, is that, I guess, the point I wanted to make there. He was monitoring the systems, making sure everything was still go. It was flying on the course that he'd set up for it to fly into that rope. And I was outside to making sure the ship didn't turn in front of the airplane, because if we missed the rope, we didn't want to hit the ship. Here's some photographs that were taken from this aircraft. A couple ribbon seals, or spotted seals and a ribbon seal. They're not looking at this guy. They're doing what seals like to do. They're just taking naps. So it's kind of a proof evidence that this aircraft did not startle them. I don't know if they thought it was a bird, they didn't hear it and see it, I don't know. Operation in the Crazy Mountain complex in 2009 for wildfire. Over this fire, they had not flown manned aircraft in 5 days because of too much smoke. And the fire crews had not seen, they see satellite imagery, it tells them where the fire is at, but this is the Birch Creek. And here's fire on the far side of Birch Creek. All the satellite told them is that there's fire in there somewhere. The creek was the fire line. Which side of the creek's it on is kind of important as to how they're going to respond to that. Are they going to evacuate? Are they going to have to put more crews out to deal with that? So we were able to look at those pictures with a thermal camera flying in essentially under a quarter-mile visibility. One of these bad smoky days in Fairbanks, it was really bad in Circle. The detail, the resolution we could get from about 3,000 feet in altitude is actually watching a single spruce tree throwing kindling and throwing off embers. So that's the kind of the quality of imagery, and we could map the fire line for the fire service. In Alaska, no one really cared so much about how many acres burned, but which side of the fire lines it's burning is kind of important to them. Nice, it doesn't need a runway. It doesn't need a runway for takeoff or landing. So we did another experiment down in Anchorage. This is a training exercise with FEMA and the state of Alaska's Homeland Security, looking for, they simulated a major earthquake in the Anchorage Bowl. And they wanted to see how the emergency responders could interact. Our task, we actually were flying with a civil engineer tasking us to look at the bridge structure of this train trestle to see if the train bridge had been compromised in the earthquake. They were trying to figure out how to get our data into their command center and how to get their directions out to us. It just so happened to be, it was only a training exercise. Alaska Railroad was still operating, and so we managed to capture a train as it crossed the bridge. We're about half a mile away from that bridge, 3/4 of a mile away from the bridge at that point, to give you a feel for the distance this aircraft's out. So here's a problem we're having out. This is last summer in June. We're actually going out again in March, out in the Aleutians. The stellar sea lion population in the western Aleutians the population's crashed. They've been listed as endangered species. As a result of that biological opinion, they've closed 3 fisheries. Alaska mackerel, some pollock fishing, things like that. Well, they have very poor quantity of data about how many animals there are and how the animals actually use their habitat. They will fly a manned aircraft out from 200 miles away from the nearest airport, out ADAC or Attu, and fly out looking for these spots in the Aleutians where these animals haul out. And the challenge with that is that they get there, and it's cloudy. They have to fly 1,000 feet altitude because of mountains nearby, and they can't get the imagery they need, so they try the next day, they still can't get it. They're usually less than 50% successful in getting the imagery they want. So our question was, could we use this technology to fly off of a fishing boat or off a research vessel, fly under the weather, fly in these little sucker holes in the weather, you have the clear skies for half an hour and no one knows it 300 miles away from there. Could we fly in those spots of time and actually get imagery of the haul outs that would be useful to help them do their counts and understand the animal migrations, the branded animals, the marks on the animal. So the ship is set about a mile offshore, and we're basically watching this rock peninsula outside of Dutch Harbor. This was just a one-day prototype we did in June. We're going out again for 3 weeks in March to do an extensive area with 3 different aircraft. In thermal, so these animals are warm, obviously. Black, they're hot. So I can use this thermal camera to help identify where to take the photographs to get a better comprehensive count of the beach line, of the shoreline. So this aircraft is right here. He's coming in to land, and it lands. I have to joke, the people who actually helped us fly this aircraft said they built it for the seals, but not these kind of seals. These, if you get a feel for these, uses these airplanes originally. So I let this guy talk.
Techniques that have been developed for oil spill response were developed over the years since the first National Contingency Plan in 1968. And what we're trying to do is use the new technologies that have developed over the past 10 years to up our game, to make us more effective, more efficient, to be able to conduct our operations and conduct our tasks with minimal impact and with maximum fidelity.
Outside of Valdez last July, this aircraft was described by the known reporter as a flying smoke detector, which is about it's about 2.5 pounds, about 8 inches in diameter. The question was, again, we had some ground-based safety devices on board with us to look for other ships or other aircraft in the area. The question was, could you avoid having to put a human on the beach to do this shoreline monitoring, shoreline analysis, if you will, for a spill response? Could you only have to put a human on the beach periodically rather than continuously walk the entire beach line to prepare for an oil spill? And we were able to fly these aircraft effectively at as low as 6 feet in altitude down the beach, half a mile, 3/4 of a mile from us. And you could basically imagine walking around with a 5-megapixel camera, a little still camera, taking photographs. And that's what you could do with these without ever having to get there. These aircraft were actually purchased by BP during the Deepwater Horizon oil spill. They never flew them in the Gulf of Mexico. They actually did bring them to Alaska, and we've leased them from BP to use for this experiments, looking for oil spill response. How would you use it? How is it suitable? What are its limitations? This little aircraft is made by a company in Canada, about 25 employees right now.
Well, just to frame this thing, this is a brand new toy, and essentially it's a roving camera eye that we can use to detect where oil is at the very beginning of a spill. Now, probably its best uses are areas where we can't get a crew fast enough or a helicopter isn't available. But we can launch this little robot into the sky and look over certain beaches, particularly sensitive ones, wetlands, areas of peat bog and marshes where travel would be difficult to get to, just to gather an initial impression of degree of oil stranding or oil presence, yes or no. SCAT is typically an ongoing process during a spill. We like to use this tool as we maybe call it a pre-SCAT.
So, as you can tell, I probably don't like to talk a lot, so I let others talk for me here. Here's a project that we were fortunate enough to be a part of last summer a little bit. We may continue it again this summer. This is a U.S. Air Force captain flying a hand-launched Raven. There's some 20,000 of these manufactured now for the Army, Marine Corps, Air Force. He was actually flying off of an icebreaker, a Canadian icebreaker in the Canadian Arctic. And here's a picture of the U.S. icebreaker Healy. The ships were working together. Thermal camera. He was looking at using this technology to help pilot ships in the ice, to help evaluate whether, what kind of information collection tools would be available for a military operation in the Arctic. And would this technology work? How does it work? Is it effective or not? He had some successful flights on it. So much so that we're looking again to go back this year, perhaps 3 months, with one researcher we have in a team to go out with some of these aircraft again on the Canadian ship. This is in November. I'm kind of going through sequentially in time. Up in Prudhoe Bay, the concern with these fire flares are the nozzles can wear out. They run these continuously 3, 4, 5 years of time before they shut down. And so the question was, could you actually take get this aircraft in close enough to these fires to image the nozzles to give them the quality data. Now the still photographs, you're just watching video here. This is pretty poor quality video actually, but the still photographs were, again, these 5 megapixel high resolution stills. Could you get in close to the nozzles and look at them as they burn to get an appreciation of how it's burning? Is it wearing out? They're getting shut down this summer for maintenance, and they wanted to get some advanced knowledge to know what parts might need to be ordered, if anything was working properly or something was broken. So again, we took the small aircraft up to experiment that. The first time we ever flew around things, flew underneath things, and we're a little more disturbing, especially you're out there a quarter of a mile away, and these fires can become 200 or 300 feet, and these are the pilot lights. The fires can become 200 or 300 feet in altitude if they needed to, if there's a failure in the system in the oil flow. I'm Greg Walker. I work for the Geophysical Institute at the University of Alaska in Fairbanks. I'm the Unmanned Aircraft Program Manager. I'm one of the pilots of the system that we're flying here. Last week, we were asked by the Alaska Department of Environmental Conservation. I thought this was a great tool to image the shores, image the coastlines. And they thought it would be really nice to have some imagery of the area so they could better understand what they're dealing with in the ice. And as you climb around in this ice, you don't have the perspective that you do from 50 or 100 or 400 feet up.
So we're trying to get a ground map for the DEC guys so they know what they're going to encounter bringing the fuel ashore and things like that. And we went out and got some surveillance imagery of the ice to the Coast Guard. So they gave us a point where they think they're going to be able to put the tanker. And we went out there, hovered above that, got some shots straight down, and then got some shots looking all around to see what potential hazards are out there. The success or failure of this mission will be pretty clear, and I don't know, how big of a role we play in that, but they're either going to get their fuel or they're not going to get their fuel, and so it's a little different than just collecting scientific data.
I come here probably 3 mornings a week or 4 mornings a week and have coffee with Pat. He's the owner, Morgan's Enterprise. We've had a real cold spell. It's probably been to 30 below for over 2 weeks straight now. Every night getting way down and sometimes staying that low all day long. We have about 300 miles of road that just goes out of Nome and stops. Everything that we have here in Nome has to either come in by ocean or by air. Fuel, groceries, supplies, building materials, whatever you want.
Your furnaces do not stop in your homes. That's, like I say, is the expensive one. Your cars have to warm up extra long.
$54 for 10 gallons. Owie, owie, owie.
I think it was like $5.43 a gallon, nearly $6 a gallon, probably after this barge, the fuel barge. We need help.
This is just showing you where you're flying, and then here's your video feed. And so this is just, like a Google map. You can pan it around. You can, we can zoom in and look at our flight paths. You can lay out a predetermined flight path, and then you get up in the air and you click on it and you hit play, and the vehicle will automatically fly this path. So you can just focus on aiming your camera and getting the video and still imagery that you want.
No, we're not saving Nome. We're just here to help out. Nome needs the fuel. Nome doesn't want to have to fly the fuel in. I can appreciate the cost of fuel. They don't need any higher price, so helping them get the tanker in is kind of fun. This aircraft launches off of a small catapult. He's basically setting it up on the catapult. During flight, you actually interact with the aircraft very little, but this is essentially the tablet we fly from. This aircraft, again, was designed for surveyors, actually by surveyors for surveyors. And it doesn't, you don't tell it where to fly as much as you tell it in flight. You have the ability to say, stop and crash, or come home and land. 3 commands. Don't take a lot to be trained to know how to use 3 commands. You basically prepare everything in advance before you actually launch the aircraft that just launched here. Again, it's the wingspan and the weight of an Atlantic seagull to give you a feel for it. It's made of foam. It's probably fairly, the propeller's behind, so it's probably fairly safe even if it did hit you. To give you a feel for how we use this for surveying, and you'll see this also in some of the products from NOAA in a minute. On the range, we actually had these are 18-inch diameter vinyl discs, little pie plates, essentially. Look about a piece of a pie plate, piece of vinyl fabric cut out. We surveyed those in around the range. So there are several of these spots, and they show up in our photographs. So we know precisely where those are. Then we take a series of photos of the airplane flying back and forth across the range. We can then take a series of pictures. You know, this one vehicle, this one truck is showing up in all these different photos. Take a series of photographs with a lot of overlap. And essentially are generating a stereo vision. So we're getting elevation data from any feature on the ground, a tree, a hill, a mound of dirt. We see that in several different photographs, and we can correlate its orientation, and we then can warp the photographs around the terrain. To give you an accuracy feeling for how this works, the horizontal accuracy that those control points were surveyed in was 1 to 3 centimeters. So they knew the position of those pie plates within 1 to 3 centimeters. Our error in registering those in the camera was 0.3 to 1.5 centimeters. Our error around the absolute accuracy we had in the measurement. That's horizontal. The vertical accuracy, which is where it gets kind of interesting, hills, valleys, we actually were able to determine that within 1.5 to 6 centimeters. So we were able, from these photographic pairs, able to generate basically a 3-dimensional model of the ground. The technology, the software for that, the structure for motion software, originally was developed by the movie industry. They made clay models of a character, or maybe a very extensive model like of a dinosaur, and they take photographs of that from all different angles around this animal, this feature, this creature, and they generated in the computer a point cloud, a cloud of 3-dimensional space where all these points were on this animal, and then they could animate that. So you didn't have to make animation of every section of the animal moving all the time. You just stretch and move that point cloud generated with one good model. So we're essentially using that same algorithm, but turning it inside out, flying the aircraft around the ground and trying to understand the 3-dimensional complexity of the ground. Here's a little video. This is just a Google Earth zoom in of Poker Flat Research Range. We're up about 30 miles north. It's on the Steese Highway right in this crook of the road here. This is the Steese Highway. It kind of turns. This is just Google Earth. Nothing special here. You can use it. This is satellite imagery. And I will now turn on a mosaic in a second here. We'll turn on. Where's it at? The map will show up in a second. Hopefully I can see it. It's a little dark up here on the screen. Oh, here. Now I have a map. This is actually the area we mapped with the unmanned aircraft. So as we're zooming in still, zooming down in from this space resolution to get the features and the details in those photos. So as we zoom in further and further here, pay attention to this area right here. There's some heavy equipment parked here, some tractors, some dump trucks, some pickups. And ultimately, I have that resolution of the detail in the photograph of the entire space in 3 dimensions. So I can tell you how tall that truck is, not just where it was at. Essentially a 3-dimensional image, a map in 3D of that area. This, I have to apologize, this was in clearer, lighter, it would show there's bumps of trees and things like that in the photograph. We've also worked on this in coastal areas. A genuine concern for 2 problems in Alaska that we're aware of, there's probably others, on the coasts are this marine animal habitat concerns. This is actually a haul out of stellar sea lions down on an island outside of Kodiak. And you can see the three-dimensional feature as you kind of look sideways. You see the terrain rising as it goes up into this island of UGAC. The other concern is on the Arctic coast, we have this extreme erosion because of the later freezing of the ice and the storms. You're seeing more and more coastal erosion, and there may be some value in actually having these high-resolution maps of coastal regions before and after storms to understand maybe the effects of erosion. Here's Nome. So here's the outer harbor. This is essentially where they docked the ship, the Rinda parked, and about half a mile back here to where they were actually pumping fuels. This is the inner harbor. This is the breakwater, they called it. On this far side, 2 breakwaters in the entrance. So you can see here some ice ridges and some rubble. Here's an elevation model in the same area with false colors. So you can see the more purpley areas, the higher the ridges were. What's interesting to see here, though, is not just, this is about a little over half a mile out and maybe a quarter mile wide. The resolution, up here, there's this vehicle, and I think this is myself and Jay Skaggs outside watching the flight. So this is the resolution I can give them of this entire area that you can see. They were using these then to look at spill. If they had an oil spill, where would the oil go? Where's the low spots? How would they pool it? They looked at the imagery also to plan a route for the hose and plan the response, emergency response. Some other things they look at is with oblique shots. We're looking at the ice ridges and trying to get an understanding. It just kept people off the ice, which was considerably unsafe. Beyond this ridge, the experts, beyond this ridge right here, the experts considered the ice could move within just a few hours' notice. It would actually could go out to sea and be peeled off of the earth, off the surface of Nome. And so there was real concerns about people getting out there walking around on it. And by taking photographs, and one person had to go out there and look around, we took pictures of it and then they could explain to everyone else in the group what they were seeing and how they interact. We have some projects this coming summer to look at Arctic Ocean with unmanned aircraft. Department of Homeland Security, the Coast Guard, have actually funded us to try to use this aircraft, this bigger one, to pilot the icebreaker in the ice, to do essentially what they were doing in the last few weeks with a C-130 or a helicopter as the icebreaker Higley and Dorinda went back out to open water, to dedicate an aircraft so essentially the captain of the ship would have their own eyeball that could go out 15, 20 miles ahead of them and look around, look for open lead, look for thin ice, look for the bad ice particularly to stay away from. We also have some shore-based research with NASA looking at how to use these aircraft over the Arctic Ocean for climate change studies. Some of the instruments that have been built for this plane in particular, this is actually a police radar gun, LiDAR of laser gun, laser speed gun, modified a bit to actually measure the elevation of the ice. So here it's flying over some sea ice. This is a color photograph of the sea ice. This actually is a radar photograph taken by a synthetic aperture radar, basically a radar camera that we can carry on the aircraft. And the LiDAR shows you the elevation of the ice and the roughness of the ice. So you can get a feel for how tall the ice is, how thick it is, as well as, well, the height above the ice water level tells you how thick it is, and the roughness of it tells you maybe how old it is. Again, so this is a scientific payload designed between us and the University of Colorado, and we've integrated it for this aircraft. Another one that we put together for this aircraft with the Ball Aerospace, which is a defense contractor in Colorado, is a sea surface temperature sensor. So this measures every pixel in the photograph to about 0.2 degree Fahrenheit of the surface it's looking at. It's calibrated really for sea surface temperature ranges, so it's not going to work well for hot things like fires necessarily. It's also packaged to fit in this airplane, up in the nose of this airplane. This is a picture of it flown over the Deepwater Horizon. We did not fly it on an unmanned plane down there. We actually put it on a manned aircraft. There was so much air traffic over the Gulf of Mexico during this oil spill response. The FAA did not want us to be in the middle of that. So we put it on a manned aircraft and flew it to evaluate the sensor. This aerosol sampler, this little payload, was designed actually here at the Geophysical Institute. For years, they've been using these to collect a different version of this that sits in a big suitcase, a small, or like a carry-on size suitcase, to collect aerosols. They'll set them out in Iraq, they've been in Afghanistan. A couple years ago, I think there was a presentation here at the Alaska Science talking about these aerosol collections. They do collections for particulate matter in the air, and then they can do studies on the aerosols to determine the composition, the chemical composition, or the biological elements that are in the aerosol, the spores or bacteria or whatever might be in the air. And they do this in the combat zones for soldier health, to look at soldier health issues. But often she set these instruments, the researchers set these instruments out near volcanoes during eruptions to study what happens to fallout from the volcanic eruptions, for example. She's collected wildfire smoke aerosols. What we're working on here is to build it small enough and light enough to carry one of these aircraft. So now we can fly it into the aerosol generation device, be it a wildfire smoke or a volcano. An active volcano is actually probably the first places we'll try to fly this. A good place to put an unmanned airplane. Not the place you really want to fly a manned aircraft is into an active volcano caldera. But if you have the data from that, you can determine what is being ejected and what size it is, the aerosols. It can help validate some models. And then it can help, the models can be validated against satellite data. So the concept is to really understand what the satellite is seeing, you need to understand the model better, and to get that in situ data, that data set in those hazardous spots is kind of where I think the unmanned aircraft may fit well. So we've been building both this sensor as well as some other more active sensors that detect the aerosols in the volcanoes. That's a NASA and a Air Force projects ongoing there. We have, I don't have it here today, it's actually on a manned aircraft right now, a small synthetic aperture radar. So this is an instrument that essentially transmits radiation, just a radar signal, but as it moves, it can get the returns vary, and that can make a photograph of the reflectivity of whatever it's flying over. Often are these on spacecraft, and there's actually a large group at the university that do research on this from space-based sources. The resolution we get though when we fly these on an airplane, this airplane size, is individual trees laying down in a burnt forest. So now I can see under the snow, through the smoke, through the clouds, I can see unburned, burned vegetation levels. Stuff you don't see from the space data. The space data will show you, much larger pixels, but also a much larger area at the same time. Other things you can't do with a spacecraft SAR that we're able to do with these aircraft is actually fly around an object of interest. Spacecraft are on these long orbits, and they're going around. They're flying a linear route over the top of a piece of terrain. I don't have that really restriction. I can fly a circle around an object and actually radiate it from different sides, so I can then get a composite image that shows a little more insight. This is actually buildings and trucks here. This is that same equipment line we saw in that other photograph with the heavy equipment parked. Heavy equipment parked here on line. You can see the different trucks, the building, the roads. It doesn't look the same in this as it does in photographs, but this is not a photo. This is actually radar radiation reflectivity. This is some work last February with this instrument on a manned aircraft up in the Brooks Range. You see these little snippets are coming down and mosaicing together as we go across this watershed. You can see what the river really looked like under the ice. Some things we've learned that we've been working on with this, that's a nice, well, I would consider a fairly decent track and everything kind of lined up. But if you don't have good flight skills on the manned aircraft, and you can't fly as precise as you need to, like you can with these, where I know right where it's at and I can fly a very precise track, I get pictures like that. So all those black spots between those photographs are where the airplane was doing this stuff in the wind and the pilot skills that kept me from actually getting a good, consistent photograph. We don't always go unmanned, I think is the key. If it doesn't make sense to put these instruments on unmanned airplanes because of the environment, why not put them on a manned aircraft? So this pod we have FAA approved to install on a Navion out here at Fairbanks Airport. We can carry many of our sensors all at the same time and put them on a manned plane to work on the sensor development without having to always resort to the manned plane. We've been working quite a lot with the FAA and with NASA as well as the Department of Defense on ways to integrate these airplanes safely with other aircraft in the airspace. This is essentially an air defense radar that was designed to protect a piece of infrastructure in the military from an attacking airplane. And so they set up near their logistics point, and it can monitor air traffic out about 12 miles and tell you if any planes are coming in. We've modified that to actually warn us if other airplanes are in the same area that we fly. So we can see airplanes 12 miles away. We can see airplanes even below us sometimes, or around, because of the way the radiation works, even around some slight hills. So we usually, the fear sometimes with manned aircraft interactions is you don't want to fly into it. We don't want to fly into the manned airplane, and they don't want to fly into this either. These little ones would be bad. This would be real bad. But if we can see 12 miles out, we can sure give some advance warning and make our decisions early on as to how to avoid that other airplane. We've also combined that radar work with some studies to look at the idea of how many airplanes are in the airspace at any one time, and how do they fly, how do they behave. We actually did this work over the Arctic Ocean and the Bering Sea, trying to prove the point that I could fly an aircraft at 500 feet in the middle of the Bering Sea, and the chance of me running into anybody else is really slim. It's intuitively logical, but I've got to prove it mathematically. So we actually were fortunate enough to have some radar data from the Air Force that we were able to work through and do some studies. And now we're building our own radar to do it other places. Another example of partnership with the FAA, there's pending FAA authorization language that it may actually get passed by Congress this spring, where there's a task to actually create a facility somewhere in the Arctic where small aircraft can operate all the time. It's particularly for climate change studies and interest in understanding the sea ice and changing the sea ice, technology for safe shipping in the Arctic as the Arctic shipping interests grow, the hazards in the Arctic Ocean, and how you deal with those hazards when you don't have your nearest air base is Kodiak, and the nearest ships that the Coast Guard have are maybe in Kodiak or maybe out in Dutch Harbor. So this program, the value to the university, why is the university doing this? Part of it is to expose the technology, new technology to the community at large, the wildfire fighters, the emergency responders. It does help our research. It adds a competitive advantage in attracting students into research activity here because we have a diverse experience with using other ways to do remote sensing. And lastly, it's actually been quite successful in attracting some students into the projects. In fact, if somebody afterwards want to talk about some stuff, on the far right, Corey is a freshman mechanical engineering student here tonight with one of his own aircraft. That's one of our employees that he'd be happy to show people how it works, what he's been working on. So with that, this is just a little cap shot in the Bering Sea over sea ice. Again, a place you don't really want to fly manned airplanes. Coming in to recover on this ship.